Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we'll be going over multiplying and dividing fractions, a follow-on from a previous video on adding and subtracting fractions. Now, to start things off, I'd like to go over the fraction 3 over 5 once again. Last time we discussed where the name numerator and denominator came from, which explains what the top and the bottom number represent. But what I didn't mention last time was this line. What does the line actually mean with fractions? Well, we can kind of already see it if we look at the division symbol. This is the division symbol. The dot on the top and the bottom represent the numerator and the denominator of a fraction. So this 3 over 5 is actually 3 divided by 5. And if you were to do long division and work out how many 5s go into 3, you could then convert the fraction 3 over 5 into its equivalent decimal 0.6. Okay. Let's start with this first example, a half of 10. If I were to ask you this verbally, I'm sure many of you could return the correct answer of 5. Now, this half of 10, this word of is an operation in mathematics. It is equivalent to the multiplication symbol. So we can write down a half multiplied by 10. Now, why is of the same as multiplication? Well, what if I were to write down something else but without fractions and using the word of? What if I were to write down 3 of 4? Now, that as a sentence doesn't quite make sense. So what if I were to reword it like this? I have 3 of these 4s. If I have 3 of these 4s, or 3 lots of the number 4, now we can see why the of is equivalent to multiplication. And so I would have 3 of these 4s, and together this would give me the result of 12, which is equivalent to 3 multiplied by 4. So a half of 10 is a half multiplied by 10. And as we know with multiplication, it has a property that we call commutative, which means we can swap the order and the result doesn't change. So this is the same as 10 multiplied by 1/2. So we have half of 10, which we know is 5, which is equivalent to half multiplied by 10, and because we can swap multiplication, we have 10 multiplied by 1/2, which is also 5. And we can visualize this if we have 10 lots of the number 1/2. So we were to add a half plus a half 10 times in a row, we could get the value of 5 that way. So let's take a look at another example. So the next example, let's take a look at 1/3 of 12. Well, using the same idea that we did for half of 10, we can change the of into multiplication. So 1/3 multiplied by 12, and we can swap the order to have 12 multiplied by 1/3. Now, in the first example, we had half of 10, which we know is 5, and 10 multiplied by 1/2 is 5. So, I propose that there's a equivalent operation to multiplying by 1/2. Well, what do I mean by this? I mean that 10 and something we do to it will give the number 5. Now, we'll ignore adding and subtracting. Multiplying by 1/2 or chopping something in half is the same as splitting it into 2 pieces. And splitting, another word for that, is division. What could we divide into 10 to give us 5? We should know that the result is divided by 2. So multiplying by 1/2 and dividing by 2 are equivalent operations. So let's take a look at this. 12 multiplied by a third. There's an equivalent division that we can do, and that would be dividing by 3. And we know 12 divided by 3 is 4. And if you want, you could use a picture. If you draw 1/3 12 times, you will have the number 4. As we can see, if I do this crude drawing here, 12 of these thirds together make 4. So, we can write down a rule based on what we've just found out, and that is multiplying by a fraction 1 over n is equivalent to dividing by that denominator of n. So this will be a useful rule for later. Now let's take a look at dividing with fractions. Okay, so let's take a look at these questions now. What is 10 divided by a half and 12 divided by 1/3? Now, because we've already worked out these previous questions, 10 multiplied by a half is 5 and 10 multiplied by a third is 4, we know that these answers can't be the same thing. So 10 divided by a half is definitely not the number 5. It's a different answer. So how could we go about working out this? Well, let's use pictures. Just like earlier, where we used the circles, this time I'll do a little bit of a different picture. So before we do the picture, let's define what division actually means. Division is how many times does the second number go into the first number. So when we do a division like 10 divided by 2, we're asking how many times does the number 2 fit into the number 10? And then we can show that as the number 5. Well, let's do something similar and see how many times the number 1/2 can fit into the number 10. Okay, so I have a crude drawing here of 10 equal squares. You can call it a bar of chocolate or something like that. Now, if this represents the number 10, then what would represent the number 1/2? Well, it would be half of one of these squares. So if I draw another one of these squares and then split it into 1/2, I'm really asking how many times does this shaded piece fit into these 10 pieces? And so I can split each of these into a half, and we can count up each of these pieces and see that we have 20 halves that make up the 10-piece chocolate bar, or the 10-piece rectangle. So we can visually see that this answer is 20. Now, I invite you to try the same thing with 12 divided by 1/3, and if you've done it correctly, you should see that this results in 36. Now, I'll propose again that dividing by a half has an equivalent operation. So what if I were to write down this? "10 multiplied by something will give us 20, and 12 multiplied by something will give us 36. I'm sure you can fill in the result, multiplying by 2 and multiplying by 3. So, dividing by a half is equivalent to timesing by 2, and dividing by a third is equivalent to multiplying by 3. So, as a reverse of the rule that we wrote down before, dividing by a fraction 1 over n is equivalent to multiplying by that denominator n. And again, this will be useful for later on. Now let's move on to a harder example. Okay, what about if we try multiplying fractions together? In this example, we're going to try looking at 1/2 multiplied by 3/4, or you could say 1/2 of 3/4. how would we go about doing this multiplication? Well, let's visualize it and then we can understand why we're going to do what we do. So I'm going to begin by drawing the 3/4 as a circle. So a full circle would be like this, but we're only starting with 3/4 of it. So I'll erase this section. Now, I'll split this into its 3 separate quarters. So we literally have 3 of these quarters. Now, if I want to have half of this 3/4, I can begin by splitting each of the quarters into 2 pieces. As we remember, a half of something is the same as dividing by 2. So, this quarter can be split in half, this quarter as well, and this quarter as well. Now, how big is each of these slices? They'll be less than a quarter, and in total, if we were to complete the circle again, we could see that there would be 8 of them inside of a whole. So each of these pieces is 1/8, or 1/8. So the question is, what is 1/2 of 3/4? So by splitting the 3/4 into half of each of these quarters, we can see that the first quarter halved is an 1/8, the second quarter halved is another 1/8, and the third quarter halved is another 8. So an 1/8, an 1/8, and an 1/8, that's 3/8 in total. So we can visually see that this answer must be 3/8. Now if you were to look at the numerators 1 and 3 and the denominators 2 and 4 and then look at the result of 3/8, we can see that the 1 multiplied by the 3 gives us the 3 and the 2 multiplied by the 4 gives us the 8. This shows the rule that we're about to write down, which is that multiplying the top numbers together and multiplying the bottom numbers together can give us the final fraction. Now, there is another way that we could work out the answer of 3/8. What if we were to use equivalent fractions? Well, we could write down 1/2 multiplied by 6/8, as 6/8 is an equivalent fraction to 3/4. Now if we ask the question, what is half of 6 of these 8ths? We can also equate that to a question like, what is 1/2 of 6 of these things? Well, it'll be 3 of these things, and these things that we're talking about are 8ths. So we can have 3 of these 8ths using the same idea. So that's another way that we can visualize or understand why the final answer is 6/8. Pardon me, 3/8. So our rule that we can write down is that if we have a fraction a/b multiplied by a different fraction c/d, we can multiply the numerators. So we have a multiplied by c as the new numerator, and on the denominator we will have b multiplied by d. So that's the general rule for multiplying fractions together. Now, we haven't checked if the final result can cancel down. That'll be something to check afterwards. In this example, 3/8 does not cancel down to another equivalent fraction, so we can leave it as it is. Okay, now we'll take a look at a few examples. Let's start by trying 2/3 multiplied by 5/7. Well, if we use the rule that we did earlier, we could work out 2 multiplied by 5 on the numerator and 3 multiplied by 7 on the denominator, resulting in a 10 on the top and a 21 on the bottom. None of them share any factors, so this does not cancel down to anything. We can leave it as 10 over 21. Let's take a look at the next example. Now, this question, 4 over 5 multiplied by 10 over 11, we could work it out the same way, in which case we would do 4 times 10, which is 40, divided by 5 times 11, 55. And then, looking at this result, we'd then have to look for the highest common factor between 40 and 55, which is 5, and then cancel down into 8 over 11. However, there is an alternative way that we can work this out. What if we were to go back to the multiplication, and rather than doing the 4 times the 10, because the order of multiplication can be switched, what if we were to swap one of the numerator pair or the denominator pair? So what do I mean? I mean that this final result can also be achieved by, let's say, swapping the 11 on the bottom with the 5 on the bottom. As we can see, 4 multiplied by 10 is still 40, and 11 multiplied by 5 is still 55. But if you take a closer look at this fraction, 10 over 5, 10 divided by 5 cancels down. They have a common factor of 5. So this can become the number 2, and this can become the number 1, in which case the final answer, 4 multiplied by 2 and 11 multiplied by 1, gives us our final correct simplified answer of 8 over 11. So rather than multiplying first and then cancelling down, it might be better to look for the common factors first and then multiply after cancelling down. So ideally, if we want to save time, we would answer the question like this. So before doing any multiplications, we can look for any common factors between the numerators and the denominators. It doesn't matter where they are, as long as there's a numerator, in this case 10, and this denominator of 5, because it's equivalent, as we saw earlier, by switching multiplication, it's equivalent, we're allowed to cancel right here. This 10 divided by 5 and this 5 divided by 5, which then gives us 4 multiplied by 2 and 1 multiplied by 11, giving us our simplified final answer of 8 over 11. So try this for yourself, and hopefully this will help save a lot of time and effort in multiplying fractions together. Okay, so for our next example, we're going to take a look at how to divide by a fraction where we don't have the number 1 on the top. So here we have 6 divided by 3/4. So this might look like a complicated question, but let's explore exactly the same way as earlier. What does it actually mean to divide? This question is asking how many times does the number 3/4 fit in to the number 6? And you can see I visualized it here with 6 whole circles and a 3/4 of a circle. So let's physically try to put this shape into these 6 circles. So we can fit it in once, twice, 3 times, 4 times, 5 times, and 6 times. Now that's to begin with. We still have these leftover pieces. Now how big are these leftover pieces? Each of them are 1/4. Now we have 6/4 remaining. So we have 6 times that we can fit the shape in, which I'll shade in, and there's a remaining 6 quarters that we haven't used. Now, this 3 quarters, we could split it up into the separate 3 lots of a quarter. So I'll draw it in blue. This 3 quarters is made of 3 separate quarters. Well, I can have these 3 separate pieces fit here, here, and here for an additional 1 time. And then here, here, and here for an additional 2 times. So together, the 6 plus the 2, visually we can see that this will fit 8 times in total. So the answer, visually speaking, using these diagrams, we know the answer should be 8. So what operation can lead us to get that correct answer of 8? Well, there are quite a few methods to do this. I'll go over a few of them now. So to begin with, I'll go over the most common method that's taught in schools, and that's the keep, flip, change method, or take the fraction 3 over 4, flip it upside down, or the reciprocal of it, 4 over 3, and you change the division sign into a multiplication sign. And this is an equivalent operation. Then we can work through it as we have before. We can do the 6 multiplied by the 4/3 by dividing the 6 by the 3 in the same way we looked at the fractions multiplying together. 6 over 1, if you want to write it as a fraction to help you out, you can do it that way. Then you can cancel the 6 and the 3 to get 2 and 1, and then the 2 multiplied by the 4 is the 8, and the 1 times the 1 is 1. 8 over 1, which is equivalent to 8. Now, the keep, flip, change method is correct. I'll write down what that actually means. It means that dividing by a fraction a over b is equivalent to multiplying by its reciprocal b over a. And you can think of it as a combination of the 2 previous rules that we went through earlier. Multiplying by 1 over n is the same as dividing by n, and dividing by 1 over n is the same as multiplying by n. This is just a combination or a more general version of that. But let's take a look at why keep, flip, change works. Okay, so what I'm about to do might be a little bit complicated, so I'll try to go slowly and hopefully you can follow along. I'm going to start by writing down a general fraction divided by another fraction. So if we use our definition of what a fraction is, like I said earlier in the previous video and in this video, 3 over 5 literally means 3 of these fifths. And using what we learned today, of is times. So we can say 3 of a fifth. So 3 over 5 is equivalent to 3 multiplied by 1/5. We'll use this definition to split these fractions. Okay, so I've written down the a over b as a multiplied by 1 over b, and the c over d, I've put it into brackets to make sure that all of it is being divided by this division symbol, and I've split that into c multiplied by 1 over d. Now, this is the tricky part. Because this division is multiplying the bracket, or acting on the bracket is probably more accurate, we can then divide by both the c and divide by the 1 over d, which would be an equivalent operation. So this is what that looks like. We are dividing by c and also dividing by 1 over d. So by dividing by c and dividing by 1 over d, we now have this, dividing by c, dividing by 1 over d. So we'll use our knowledge of BIDMAS, that division and multiplication are equivalent in terms of priority. We can do them in any order. But before we do that, I'm going to change the division by 1 over d using what we learned earlier, because that's equivalent to multiplying by d. So this is a multiplied by 1 over b divided by c and multiplying d. So now let's use our knowledge of BIDMAS and swap the division by c and the multiplication by d around. So we can go back to the a multiplied by 1 over b. That's still a over b. And we're multiplying by d divided by c. Now this d divided by c, we'll use our definition of the division symbol. Remember, it's a blank fraction. We can put the d on the top and the c on the bottom. And there we have it. A over b divided by c over d is equivalent to a over b multiplied by d over c. So hopefully that explains why the keep, flip, change method actually works. So we're not mindlessly doing mathematics. We now understand the why or the how as to why and how we can keep, flip, change, or flip the fraction, change the division into a multiplication. So let's try this out now on an example. So here's our example. 3 over 11 divided by 9 over 14. If we were to use our keep, flip, change method, we can keep the 3 over 11 the same. We flip the 9 over 14 into 14 over 9, and instead of division, we have our multiplication. Now we can do our cancellation. The 3 and the 9 can cancel. 3 is the common factor, and now we have 1 multiplied by 14 and 11 multiplied by 3. And we know that this is the simplest form because the cancellation has happened first. So there's nothing left to cancel in the end. So our final answer is 14 over 33. So what did you think of the video? Hopefully it helps you out. Please pass it on to anyone who you think would benefit from it. Make sure you give it a like, comment and subscribe, and I hope to see you in a future video. Take care.